Hello and welcome to C++ Weekly. I'm your host Jason Turner, available for code reviews and on-site training. Be sure to check out the video description. I've got t-shirts, I've got swag, I've got upcoming workshops. You need to go to these things. In this episode, I want to talk about something that is effectively a solved problem, but I think people still think of enumerations and switches as kind of dangerous somehow in C and C++. So I just want to show you that they're really not, and it's really quite simple to use them safely. Today's episode is sponsored by JetBrains. CLion is a cross-platform JetBrains IDE for C and C++. It is ready for your projects out of the box and has everything you need to stay productive, focused, and in control. Deep language understanding with intelligent code assistance, comprehensive build system support, unit testing frameworks, advanced debugging, and embedded development. Use the code CPPWeeklyCLion to get 25% off when purchasing a new CLion subscription or renewing your existing one. Yes, as an aside, if you didn't know this, enum struct and enum class are exactly equivalent. I've done an episode about it. Few things to point out here that you might not know about using enumerations and switches, and as long as we're talking about safety with these things, we may as well talk about the things. This is going to fail to compile. Because this is a strongly typed enumeration, I need to explicitly scope the thing. I'm now getting a helpful warning from my compiler that 4 enumeration values are not handled. And you're right, compiler, so let's go ahead and deal with these. There's a few ways that I can do this. I can provide a default, which I really don't like. Because the underlying type of this enum struct is actually an integer, the range of integers is the set of possible legal values to pass to this function. We don't think of enumerations that way, unfortunately, but that is how they work. Okay, so what happens here? Let's see, if I pass in A, what do I get printed? As you can see, I did fall through here. I print both A and B-E, comma, unknown, because it fell through from case A through to default. It's actually kind of humorous, because I intended to show you how every modern compiler will generate a warning here, instead of letting you implicitly fall through. Let's go ahead and put on GCC. Okay, good. GCC enables -w implicit fall through. At what level did we get implicit fall through? We get this with W extra in the pack of warnings that come with W extra. Let's go ahead and see if we can get this warning from Clang as well. Maybe the Clang developers decided that this is a warning that we don't actually want. Unannotated fall through. -w implicit fall through. So Clang has the exact same warning, it's just has to be explicitly enabled. You have no idea how tiring this is to me. All right, so I now put the break here and I get what I want printed and I get no errors from my compiler. There are a multitude of other ways of handling this. For example, I did an episode on this as well called Returning from the Void. Make all cases return statements. Let's rephrase this. Treat switches as expressions, not statements. I am planning to do a talk on this topic specifically later this year. Let's get rid of this default. I really don't like this default being here, and you will see why in a moment. Now, notice the 4 enumeration values not handled in the switch. Okay, that's fine. So let's go ahead and do this. Notice C, D, and E not handled. Now, notice with neither Clang nor GCC are we going to get an error here. Because I don't have anything in this case statement the compiler can see that it is clear that I intended to fall through in this case. See what I'm doing here? If I treat all of this as an expression, not a statement, then fall through becomes impossible. But also using appropriate compiler warnings makes this impossible. And there was a hint a moment ago that if I wanted fall through, then I can use this fall through attribute and make it clear to the compiler that I am intending to fall through. Let's go ahead and call this with B, and we'll see B, and then we'll see B-E printed, and we will not see unknown printed. And again, I want to point out that this is actually perfectly valid C++ code, because with a strongly typed enumeration, the underlying type by default is int. And that means that its range of valid inputs is the range of integers. We'll print C. And then we know this is some value between B and E. While we are here talking about switch statements, let's look at here. Did you know that you can put statements here? This is interesting. What kind of statements can I put here? Can I declare a variable here? Unused variable x cannot jump from switch statement to this case label. Jump bypasses variable initialization. Okay, good. That's fine. That'd be weird because everything is going to be a jump. It's always going to pass that. What can I put here though? I could do this. I can use the using enum statement. And then that allows me to simplify these if I were so inclined. Very tightly scope the import of this enumeration values to right here inside the switch statement. This is my set of recommendations for using enumerations well. Use a compiler with good warnings. You have to explicitly enable it in Clang. Hopefully you're already getting it in GCC. Make all cases return statements or restated. Treat switches as expressions, not statements. Use fall through when you need to. We saw an example of that. And avoid the default case. If the rest is an expression, then the final pathway through this thing should also be an expression. It needs to return or error or do whatever else it needs to do. This is the kind of episode that I hope leads to a conversation in your team organization after you watch it. So watch this, talk to your teammates, and report back on how things went. And thank you for watching this episode of C++ Weekly.